You are now free to move about the country. Wish you could fly? Imagine going anywhere you want with no stop signs, no red lights. Well, it's not that hard. General aviation is a great tool to have under your belt, and charting a flight is one of those general aviation need to knows. Today, my name is Andrew Sellers, and I will be talking about how to chart a flight with a standard plotter, sectional, and E-6b computer. For basic planning, you will need a sectional, which is a aviator's map. A plotter is a scale and a protractor, and an E-6b computer. It does all your calculations and conversions, makes them very simple. First step, where are we going to go? Today, we will chart a flight from Clarksville, Tennessee to Hopkinsville, Christian County. And our sectionals are broken up over the United States. Each section is named after a specific area in that section. For Clarksville, Tennessee, we use St. Louis sectional. In today's flight, we're going from Clarksville to Hopkinsville. To start, you will place a dot in the center of your departure and the center of your arrival destinations, and then use the prone edge of your protractor to connect the dots. Then you can use your sectional measurement to get a distance and wind direction. And to do that, you measure it to get your true heading. Align your protractor up with the longitudinal line or horizontal line, and whatever your course is intersecting that degree is your degree that your true heading will be. And they call it a true heading because it's in reference to true north, because your maps are printed in true north. And for today's flight, it will be 339 degrees. Then we will find our magnetic variation. As you can see in this picture, our magenta dotted line is our magnetic variation. That is called an isogonic line. And you will add or subtract the number on that line. In our case, for Clarksville, it is 4 degrees west. West is best, east is least. So we will add 4 degrees to our 339, which will be 343 degrees. Then we will make our wind corrections. And to find wind corrections, we need to know how wind affects an aircraft. It is the main consideration that will affect an aircraft, and it will alter the progress of any aircraft in flight. To obtain our weather, we can use one of the many resources. In this case, I like to use aviationweather.gov. It gives you all pertinent information in the local area and along the route of flight. You can use many sources such as aviationweather.gov, skyvector.com, and the National Oceanic Administration. Once we have our wind information for our current flight from Clarksville to Hopkinsville, our wind is 249 degrees at 27 knots. To make wind corrections, we will first set the magnetic wind direction under the true angle from the grommet under the true index, which is our top line. We'll set it at 249 degrees because that is the direction that the wind is coming from. Then we will mark a wind dot up from the grommet to indicate the actual wind. You can see it's 27 knots. So we've set the grommet at 100 and marked up 27 knots. Then we will set the magnetic course under the true index. So our magnetic course was 342 degrees. We'll rotate that to 342 degrees, as we can see we've done here, which will bring our wind dot off to the left, which will be a negative degree. We will have to subtract degrees to make wind correction. Now we will slide the scale up so that the true speed arc is under the wind dot. As you can see in the picture, we have slid it up to 110 degrees or 110 knots, which is the true airspeed, and our true ground speed will be under the wind dot, under the grommet. So we will have, that will be 14 degrees, subtract 14 degrees, 342 degrees minus 14 degrees is 352 degrees. And it's that simple. Still wish you could fly. I hope I've taught you all to learn about how to chart a flight, and I hope I've inspired you to get into general aviation and keep the dream of flying alive. Thanks for coming.
Thank you. Awesome, dude.